Hello, everybody. Tonight is the 10th of August, and this is Dallas Personal Robotics Group Builders Night Virtual. My name is Carl Ott. I'm the current president of the club. I'll be a kind of facilitator here for most of the night, at least. In these sessions, we go around the table and talk about our robot projects, either accomplishments or plans or questions, and we just kind of socialize mostly around things related to robotics, design, manufacture, construction. We do record these, so feel free to jump in, but if you don't want to be in the recording, don't say anything, and you won't be in the recording. One little bit of housekeeping, or maybe not so little. We do have coming up just a week and a half, Robo Columbus Plus. This will be our big competition for the year. It'll be the first in-person gathering for DPRG since March of 2020. And this will be a hybrid event. We'll have probably a large contingent here in the Dallas area, Northwest, in a little suburb called Farmersville. And we'll have, I think, participants from both Seattle and Ontario, Canada, remotely. So it'll be a hybrid event. More information, I'll put this information in the chat. But if you are interested to come, either in person, especially, or remotely, or virtually, I would ask kindly if you could just register here. That lets us get a head count. We're going to get some food. Club is going to pay for some food for local participants. And we want to make sure we can let people into the Google Meet whenever we get started on the virtual part of things. So more details there in the chat. But aside from that, that's the housekeeping that I have. Does anyone else have any other housekeeping to mention? Okay. Having said that, we'll just do the usual thing and go around the table. And I think we're going to start off with, if I remember right, it's Doug and then Ted. And then it's a free-for-all, whoever's after that. So, Doug, take it away.
Okay. Let me see. I've changed my camera here. Give me a second. All right. So, Robo Columbus, 10 days. I plan to be there, and I don't know if I'll be as good as Burp, which is probably our sort of super champion on this one. But I have made a lot of progress, and I want to share that with you. So as soon as I can figure out how to do it, I'm going to do some little presentation here. All right, share. All right, so this first one I'm going to show you is a video of the basic robot using Autopilot. And this one, I had done this before and then lost the Fox and wasn't able to do it again because something went wrong with the robot or the settings or whatever I was doing. I ended up having to change the motor and the controller, and I think I've got it back working. So this is the strategy to get from the start of a waypoint to near the next waypoint. And I don't have a big area.
Doug, did you mean to show something? Because
yeah, you should see it now.
It's not presenting.
Okay, what? It's not showing?
No, we see your voice is attracting your camera.
Okay, wait a minute. Hold on a second. I don't know why it didn't share. Okay.
That's looking better.
Okay. Let me start this guy back here if I can find him. Okay, so again, this one is just a demonstration of the robot using Autopilot. Wait a minute, why is it not?
Doug, should we be hearing audio? You
Yeah,
might
you
want to
should.
narrate because I'm not hearing any audio, so you might want to
Okay.
narrate.
Okay. All right.
And is
Here it
the
goes.
platform actually moving?
Okay. This is my pilot buggy, and this is where I'm just demonstrating how the autopilot works. Yeah, I've been going over some of the functions. You can see it has a ultrasonic array in front. That I know the software for. I've got the software worked out, but I haven't actually put in the Mega yet. And I overcame another big obstacle, and that was getting the ESC to work with the Mega straight up. It was simple once I knew how to do it, but it wasn't real easy. So I got that now, and if you look at it, you can see there's a Pixie Cam in front. I'll show that a little later in the other one. I'd like to find out how to get the audio to work on this because I did this so I wouldn't have to talk to it. Here we go. So it's in Sinfeld cell phone. You see the cone, it's target. Yeah, it won't actually go to the cone. It goes to about 10 feet. And there is some ambiguity to exactly where the cone is placed because I just took Google Map and plopped it down about where it said it was going to be. So right now it's not moving because of the kill switch. So I've got to get the transmitter and push the kill switch button. And should happen here.
Question, what's the angle on your sonars?
15. So there you see it. You see it make the big turn. So it knew it was where it needed to go. And it's headed towards the cone. And it stops. Okay. Okay. So now at that point, I would go into the second strategy, which is the strategy that handles, okay, where is the cone? How do I come up and touch it? So, but I'm good with, I'm real happy with this. You might notice it's going pretty slow. The reason for that is because in my testing, I'm not running it real fast, but I could speed it up if I had to. So yeah, it looks good. Okay, now this one let me see here. Before I switch to this next one, I'd like to see if I can adjust the settings here. No.
Yeah, it doesn't look like you can grab.
Do it now. Okay. All right. So we're going to get that second one here. Now this one is on my desk or my workbench. Okay. So here, this is a kind of a close-up view. Okay. Okay. So the first thing I'm
So
going to do.
this is a 1/10 scale, I'm assuming, or is it a 1/8
Now you
scale?
see here, see this 3D part here? That's got an optical quadrature encoder underneath it, and there's a 25 tooth gear underneath that I'm reading. I try to show it, but you can't see anything in there. But it's right where my mouse cursor is. Okay, so that these wires are coming out of the encoder and over to this. This guy would normally be mounted up here, but it's easier to work with them out. Okay. Okay. Now, this is the Pixie Cam, and I'm using a strategy I used before, which is to run it to an Arduino Pro Micro and use a serial port to transfer. Now, these two LEDs will show you what the Pixie Cam is seeing here in a minute. So they'll just show left and right here in a minute. Okay, the first step was to see if the encoders were working. So I got the power turned on. I'm going to use my transmitter to just, so I'm in manual here, and I'm just going to run it at some speed to see if I'm not got, what I'm looking for is, am I missing pulses? You know, does a section of the wheel wobble out of true? But you can see here, I'm getting a steady stream of of pulses. And here I am, I'm opening up the scale. So just make sure I don't see any gaps. Now I'm going to go look at them for the quadrature here in a minute. Yeah, so let's see if I can get it. I had a little trouble getting this, let's see, I get it to lock in here in a minute. Okay, there you can see the quadrature, the 90 degrees. Yeah, so everything seems to be working okay with that encoder that I put in there. So that means that I'm not going to probably use it for actual odometry. I plan to use it for speed control. So now I'm going to look at the Pixie Cam. This is a Pixie Cam 2.1, the newest one. And okay, now I'm moving the cone back and forth. I don't know if you can see it here, but you'll watch the LED one will come on and then the other one will come on, and there'll be a brief period in the center. I didn't realize I wasn't actually showing the cone. Okay, and I think these are actually switched. I'm going to probably have to change the code. So that might be a small bug. But what it means is, yeah, I'm getting a real good signal that's indicating how far away from center the target is. Yeah. Now, the big advantage of the 2.1 is it has FOV of 80 degrees. So that's kind of nice.
What's the thing with the yellow and the green sticker on top with all the pins coming out? Like it's
That's
some
me
sort of.
trying to, when you get old like me, you can't remember where the different things go in. So
No, what is that? What is that widget? I mean, it looked like a semi clear enclosure of some sort of
yes,
device.
that is the Audi Pilot, or APM. You know, if you were looking for it on Amazon, it would be an APM 2.6. The newest one is APM 2.8. All right, but if you didn't own these already, you might want to go with the more up-to-date Pixhawk, P-I-X-H, however you spell hawk. Okay, and that might be that's a little more up-to-date. But since I already had one of these, and I'm really urging to trying to get it to use it, so that's what I was trying to do. So right now I've been screwing with trying to tune the PID just roughly. And one of the problems I'm having is that I'm not getting I don't have for one wheel revolution, I only have 270 pulses. So it's a little, so if you're trying to go slow, you quickly get into I'm only trying to ask for 3 or 4 pulses per time period. And so, you know, your thing is going, and I don't know if I can tune that out, but we'll see. I'll get out of here. All right. All right. Now, if you guys would pin on me, I'd like to show a couple of things. This was a technique to add auxiliary power after your switch that turned out to be pretty neat. If you see this, I don't know if you can see it. If you pin me, you can see it. It's essentially some XT60 connectors, a male and a female, that have been put as close as you could together, and then a piece of 16 gauge copper wire, housing wire, dropped into the connector slot and soldered across on both sides. Then your auxiliary tag wire, actually on the one that on the pilot, I actually put two. This was from my donkey car. And I put, just solder that to the proper place. Then I wrap one of the wires with tape, just for extra security. And then I choose 3/4 inch heat shrink, which you can get from Harbor Freight. Put it over, it looks like about 1 inch, and tie that on. Then you can install this in your battery path after your switch without any real problem. And it's easy to, even if you wanted to, you could add another one. But what I did is I actually added 2 tags to the one that's in Pilot Buggy. Just a cute little, I thought an idea that seemed to work really nice. Let's see. The other thing I wanted to mention is this. When I was working with the Pixie, I was on their website a lot, and this is a product that they're talking about, and it's too, they've gone through the Kickstarter a while back, and it's kind of interesting. It uses you can see a Raspberry 4 module inside, and it's got they show a couple applications. It also, the fact that it's a Raspberry 4, you can do anything you want to do with it.
I'd like to ask you about the effectiveness of your Pixie Cam if you've gotten a chance to evaluate it.
I know that the guy that's has won this contest several times with perfect scores. He's used a Pixie Cam to do it. Okay, so you can do it. You can do it. Now there's some problems that you have to watch out for. You're gonna have, oh, come on. From a light point of view, it's okay. From a light point of view, you see how I'm all washed out here? The same thing can happen. Same thing can happen to you on your out in the bright sunlight.
Yeah, I'm imagining the bright sun, and then what about when you're motion?
Now they do have a way in the newest version of the Pixie software, which I haven't tried yet. So, where essentially it will take this out of consideration. Otherwise, if it's too saturated, it just creates like spots in the image that it doesn't look for. And I don't know. I also have, let me see if I can put my hand on it. Oh, where did I put that?
On that question, I wonder if anybody's seen any robot style cameras with HDR built in. So, in our consumer phones and such,
Yeah.
multiple images at different exposure rates and meld the images into a single one. I'm just wondering if any robot style cameras, or anybody's seen any like that. HDR.
I'd have to look at that one that they're just offering right now. The one I just showed you, the Vizzy, that might have it, but you'd have to read the specs. And anyway, somewhere around here, I have 1/2 of sunglasses and a 3D printed holder to allow me to put a polarizer on front of it. Okay, so that may help a little bit. The guy that wins this all the time, he has a light sensor, and he uses it to adjust brightness. Okay.
What about motion? You have to stop to get the color right, or can you be moving so the image might be a little blurry. How does
Doesn't
that?
matter. It is strictly a blob detector. All right. So if your color is right, it will it'll pick it up. Uh, you can allow tolerances, and since these fluorescent orange cones are not really found in nature too often, you can probably get a little more tolerance there to it. But like I say, the strategy is that for Pilot Buggy is have the autopilot take me close, and then as I approach the cone and I pick it up, that it takes control using this Pololu part right here, which is takes two sets of 4 channels input and has a select pin, so you can go from they use the terminology master and slave inputs, and the idea for this part originally was to allow 2 people to fly like a helicopter, somebody who was like a teacher and somebody who was a beginner, and if he had a problem he could take control of it. And in this case, where it's going to be used is I see the cone, this takes the autopilot offline. The autopilot's not offline, it's just running in the background. Its inputs just aren't going to the throttle and the steering. Or at least this is the theory, guys. We'll just see if it, like I say, 10 days. I've got a lot of stuff to still iron out, but I'm feeling really, I feel it's possible. Luckily, I'm retired, so I don't have to, do things like go to work. So that does give me a slight advantage for this.
Doug, you're in striking range of this one.
Well, like I said, it's one of those things that if all of the bread landed jelly side up, I might actually, if you can get 3 points, then you can waypoint your way to 9 points. Okay, I probably can't do the three-way point contest yet, but if like I say, I'm going to have the array, but the array right now will be to help the Pixie Cam to find and distance the object. And you've heard me talk about the Huffy lens. Well, I'm not going to be able to get it this time, but it's still on the time for later. Both of these are essentially shortcuts. They can all be approached with many different cameras that are available out there. I mean, Raspberry Pi, the OpenMV, the MaxPi, all of the MaxPi bit. All of these can do this. It's just that this one is so easy to use that it's kind of hard to. If you're just going to use a blob, why not? If you're going to use something more sophisticated, then you're going to need something different.
Hey, Doug, what GPS sensor do you have on? Does it do just U.S. satellites, or does it do, U.S., Russia, Europe, China?
Yeah, I noticed that it locked into 16 satellites while it was sitting in my kind of narrow room with the high fences and everything, and no horizon. So it must be picking up multiple satellites. So I believe it's a U-Blot M8, but it is possible that this might be a U-Blot M6. At the time, I think the M6 is on an earlier version of one of my robots, and I think this is really an M8. So I think it's called the U-Blot. I think it's Uni 8N. The Uni part, I'm not. It might be Geo. I can't remember what there's a little 3 Neo. It's a U-Blot Neo 8M. It has the actual compass used by the autopilot is actually up on the GPS module.
Mm-hmm.
Yeah. Yeah.
So yeah, I think Spark Fun, they have a GPS unit with dead reckoning. Is that the one?
There's
Or
no.
it has an IMU in it.
This one doesn't have an IMU as far as I know.
Oh, it does not. Okay.
No, yeah. It's just if you ever gone out to the uBlock website and taken a look at their GPS utility, you can really customize one of these modules to just tell you what you want, and that can speed it up a little bit. And uBlock provides excellent utility to mess with these things. Let's see. Anything else about that? I think that's pretty much it. Like I said, I do have the bumper wired up to hit it, but what I'm afraid of is that with when the Mega takes over, I'm not sure how smooth the control is going to be now. So you might just, which is okay if it hits the target, but it'd be nice if it just smoothly went up and touched like everybody else's. But I don't know if I'll have that in 10 days.
Well, it's looking good, Doug.
Yeah, I was real worried a couple of days ago that I wasn't going to get here, but a few things just fell, like I said, jelly side up, and
Yeah.
everything is
Wheels moving. Wheels moving. Way to go, Doug.
Yeah, that is looking good, Doug.
Yeah.
I'm in a similar spot to where you are as far as the contest goes, but I have a full-time job and I can't work on it a whole lot during the week. So I might be a little bit further behind. So right now I have it so it'll drive at least on a good day to the waypoint I tell it to, and then it does switch over to I'm using an OpenMV cam, the the M7 model, and so that does the blob detection also. I have a little video of it here. I will show you. Let's see, window. Here we go. And so, all right, can you guys see that? Here it goes.
Yep, it's coming up.
So right now, what I'm showing you is right after it switches over. Well, I actually just skipped the whole drive to the waypoint and started with the switch over. So it'll start turning and looking for the cone and then drive towards it. And I have it driving real slow just to test things out, but it seems to be working out well. Can see it got right up next to it. Didn't quite touch it though. So I might adjust that. The one thing is my cone's a little smaller than the actual cone for the contest. So yeah, let's see. It oh, come on, back up here. So it stops when the blob gets big in the view. And that's something I can adjust also. Although if I set it too much, it just runs over the cone and then gets high centered and gets stuck. So it might be a better strategy to just get close to it and not actually run into it. Now, one thing
No, Ted, you're so close. That's great. That's fantastic. All you need is an ultrasonic to give you the distance. That's it.
Yeah, or just a whisker sensor. I was thinking of doing that.
And you can do that because gently touching the cone is tough.
Yeah.
Running it over is not so hard.
Yeah.
Let me get it this way. It's hard because you have to be at the cone, but you know what I'm saying.
Doesn't that front plate of yours there have a trigger on it? So when you just touch the trigger, shouldn't you know it?
No, right now that's just the passive bumper I was using to protect the camera.
Sounds like you put a switch on that thing and let it bump, and there you go.
Yeah, exactly. So
Maybe, but my robot's not going to even do any of that. So maybe I don't know what I'm talking about.
yeah, yeah.
That's a
So
good
that's
idea.
probably is my next step, is to put a switch on it. I just in a previous contest, I had trouble with the switch where it would, if the robot got bouncing too much, the switch would trigger, and that caused me a whole ton of issues. So I'm kind of reluctant to do that, but I might do it. Just set the switch so it has enough resistance that it doesn't bounce around.
That's looking really good, Ted.
Yeah, thanks.
I wish I had that part of mine done. If I had that, I'd feel really good about it.
Yeah, I still have a few issues. Like the tires, they have a little too much traction. So sometimes they'll just start digging into the grass, and it has some trouble turning. But yeah, other than that, I'm happy with it. I'm still haven't convinced myself that it'll all come together once I get there.
Ted, there's one thing you could do with the whisker sensor, is that if it's causing a problem while the robot's driving around, just ignore it and only pay attention to it when you're next to the cone.
Yeah, and so that the way I do my code, that wouldn't be too difficult actually, and that's a good idea, because right now I'm a little bit like Doug. I have different parts of the code. So the first part is just getting to the waypoint, and then once it there, it switches over to the searching routine, and then once it sees it, it switches over to driving to the cone. So I could wait till it's driving to the cone to enable the switch. And so for communicating with the camera, I decided this time just do it simple. I have the camera, it'll output digital IO pins. So I have one pin for left, one pin for right. And then if it's centered, it turns on both of those pins. And it has a third pin for when the image is big in the sensor. So
that sounds similar to what I'm doing.
Yeah, it seems to work well. I just have it. If it's on the left side, then it turns to the left. If it's seeing it on the right side, turn to the right. And I actually have the code where the robot will stop its forward movement until it gets the cone centered, and then it'll start going forward again until it's out of center and recenter. And that seems to work well.
And that's where a differential robot really has it over RC car.
Yeah.
Because RC car can't make that type of turn.
Yep. So that all works well.
That's looking pretty good. That's another applause thing for a moving robot.
Yeah, thanks.
Compared to many of us. Hey, Ted, so Jim was asking earlier to hear about different approaches and strategies and build experiences. And you shared a bit about your robot so far, but I was wondering, could you remind us, you just mentioned like the different phases the program will go through. So how will you go from waypoint to waypoint? GPS, odometry?
So, right. I was hoping to add GPS, but I didn't quite get around to that, and it was getting close. I thought I better start working on the optical stuff. So right now it is just odometry and gyro compass for heading. And so I've got encoders on all four wheels, and I combine those to get the odometry. And I've experimented with using differential odometry, but that never seemed as good as the gyros. So I just go with gyros and the compass for now and use that. This robot, because it's using the differential steering, and it's basically skid steering. So it does a fair amount of skidding, and on grass, the odometry isn't as good as I'd like. So, my one concern is that I won't get close enough to the cone to actually see it. But, we'll see when we get there. Any other questions?
Well, cool. Well done. Looking forward.
Right, thank you.
And also, it should be noted, I think Ted is still planning to drive from Colorado to Dallas. So we'll be looking forward to an in-person visit. That's really cool.
Yeah, I'm looking forward to that too. So I'll see you guys there.
Yeah. Hey, please think, while I put this next thing up, think about who wants to jump in next. But just for people who, for those who haven't, who came in a little later, just a reminder, I put in the Slack. Most of the things we're talking about tonight so far are this outdoor rover competition we have in 10 days or so. And the links to learn more about that and such are on the chat here. And if you do plan to come, especially in person, would ask if you could click the registration so we can make sure to have logistics properly taken care of.
And I just was going to point out that anyone is certainly welcome on the personal robotics chat server on Discord. I just put a link in.
Yeah, cool. Thanks. I should add that into the thing too. Okay, well, who would like to go next?
I can do a quick update.
All right, Doug.
You may hear the attack dog back there. I've been having a lot of trouble with my motor controls, so I stopped and bought this little kit, and it actually runs, so that was not so bad. And it used to make noises too. It's just a simple little plug together kit. I bought it mostly because I wanted to see how that arm articulation worked with those servers. And so that actually gave me some good ideas. I was watching Wally the other day, and he has a lot of personality. And my robots so far have no personality designed in. So I wanted to have more personality, and this guy's got it. So I was using it as a prop to help me think about adding personality. And that leads me up to, or segues into how I started, is that I was having a lot of trouble with my motor controls. Turns out these little motors I bought recently to replace the continuous rotation servos that were giving me so much grief, they have no torque. They spin really fast, but as soon as you touch them with any strain at all, they stop completely. So I need better motors. And that leads me up to the question, 5-volt or 12-volt, what do you think?
Well, are you using N20 motors or are they some other kind of motor?
It's a little bitty hobby motor that I bought.
You got to use a gearhead motor.
This is the package that I got them in.
Yeah.
And I didn't really think they would work, but they're like 10,000 revolutions. So they got lots of speed, but no torque.
Right.
Yeah,
So
you
I
need a
need to
gearbox.
I know Ted is using yellow jackets, and I looked on Amazon where I get most of my robot parts. They didn't have yellow jackets. I went down to the Micro Center. They didn't have yellow jackets. So nobody local has really got good motors. So I need to decide where am I going to buy my motors and what kind of motor I need.
I think you want something with a gearbox with metal gears added to it.
Right.
And one he's showing might be good, but have them all built in.
Yeah, I was wondering, what is that?
Okay, this is, if you go to Servo City, they sell yellow jackets, which are coming from Go Builder, which is the same company. This is a 22 millimeter rather than a 25 millimeter motor, and it comes in different gear ratios. The benefit of this one is it's actually got ball bearings on the output. I was taking Doug Paradise's advice, and this has actually got ball bearings on the output, and it fits into their whole scheme of mounting things. So you can mount it on maybe just buy one mount and then like this L bracket thing, but you could buy a whole robot versus parts. But these 22 millimeter motors are pretty powerful, and they have a nice a stainless steel D shaft on them. But the 22 or 25, you get pretty torquey motors when you're getting up to 22 to 25. The little tiny N20 ones are, if you go 12 volt high power, I think they've got like a stall current of like 3 amps. So some of the small N20s for a small robot are certainly big enough. But I think I've mentioned I'm working towards a Mars rover, a small Mars rover, and I'm going to go with the 22s because they've got, there's quite a lot of torque on this thing. And the gear ratio is obviously you just go down to a higher gear ratio and you get more torque, lower speed, higher torque.
So those are 12 volt motors?
This is a 9-volt, I believe.
Yeah, the yellow jackets are 12 volt, but they are probably overkill for most robots. In fact, they're overkill for my robot. They're big, heavy motors.
Yeah, they're big. They're very powerful.
Yeah.
Yeah, well, I'm just trying to drive around my little telepresence robot. It doesn't have a lot of weight, but
Yeah. So you don't want yellow jackets; they'll be too big for that.
No, and then I think, Doug, the big question would be, this is a 22, and then on my other robots, I've got 25 mil. And so this is actually a more powerful motor because it's a more expensive, higher quality with the ball bearing shaft. So if I were you, I'd look into these on Servo City, but then the next step down from this would be N20s. And they come in 6 and 12 volt, low, medium, and high power. And I think as we've discussed on here, if you go to the really, really high gear ratio on the 12 volt high power, they've got enough oomph in them to actually tear apart their gearboxes. They're so strong.
Yeah, Pololu's was the most important piece of information there because I really needed a better source than what I was using.
Well, Ted said Pololu, and they're Pololu's got the best selection of motors anywhere.
Yeah, they have a really good selection. Their micro metal gear motors are really nice motors.
Yeah. Those are N20s. Ted.
They were
okay. Oh yeah, N20s.
They're distant for US though, aren't they? Do they come in like in a month or so?
No, they're in Las Vegas.
Oh,
yeah.
Okay.
Yeah, and they're a private company. They're actually a nice small company.
Yeah,
they've
like been a long-term
motors on a lot.
So like those are N20s.
Okay, that looks good enough for what I'm thinking. And
yeah, I mean this is a relatively heavy robot, and this is 4 6-volt motors, and they're plenty powerful.
Okay. Well, good.
And these aren't even the high power ones because the high power have such a high stall current that I'd have to go to a higher motor controller. So I'm just using the mediums.
Okay, cool. Thanks. Y'all solved my problem, I hope. I've been killing myself with this motor part. I'm wanting to get back to the software part. I'm not a hardware guy.
Yeah, I'd recommend the Polu motors also. I've used the micro Polu motors, and those little motors, they turn anything you want them to turn.
That's it for me. Next.
Well, cool, Doug. That's looking really good. Hey, just a dumb question about the contest. Are you still thinking to have the your telepresence thing available?
It will not be ready by then. I don't.
Not ready. Okay.
I mean, it doesn't move.
Oh.
I've got this little. I bought this thing, which has more of those little yellow motors on it.
Yeah.
I may have that, but of course it would only be good on a straight flat surface. And
Okay.
y'all tried to drive my little car around. It couldn't make it over a little bump. It's got those same motors on it. So I doubt if it would work. I just bought that as another thing that I could use to be a base for some small mobile robot.
Okay.
I got carried away at the Micro Center.
Well, Doug, oh, go ahead.
It's a fun place to shop. I was just going to ask if briefly if anybody in the call is planning to come in virtually. There's a chance that I could make a tweak to mine where I was thinking to have it sit on a table where you could at least pivot it around. Is anybody on the call? Would that be of value to anybody on the call that's joining virtually? If it would be, I'd try and make the effort to do it. Otherwise, I'm going to focus on other things.
Is there going to be a recording or parts of it at least?
At least parts of it, yeah, for sure. Okay. Oh, moving on. I'm sorry, I interrupted you, Marie.
What day is the contest?
I wasn't sure if it made it into the list or not, but I had sent a message about the different robot environments. Did anybody get that on the mailing list?
Yeah.
Basically, what I was trying to do is that it had came out of a conversation where I was trying to enumerate the different kinds of like smooth surfaces all the way to like up in the mountains, wild environments. So when we talk about robots, like a robot that's designed for a smooth floor certainly isn't going to get across the grass, and it's certainly not going to get up a curb. And the idea was to say, okay, these are the different kinds of environments that a robot might work within or in, and then it kind of clarifies a little bit when people are designing or thinking about their own robot. Where do they think that robot might be suitable? Because it's pretty common in this talk about whether a robot can get up or down a curb or not, but certainly none of the robots I'm working on I even think would get up a curb because they have too small of wheels.
I must commend you. I must commend you, Murray. I've read that, and you're one of the most complete individuals I know, because not only did you talk about getting over curb, you talk about, you know, this thing has to operate in space. What would you think about that? I thought that was awesome. I got a little chuckle out of that. That's fantastic.
Well, NASA has robots that are in space and also robots that land on planets. So I was going for everything.
Completeness, man. You got it. You got it down.
And comets and meteors and
I don't have to worry about that. So
Doug, this is my kind of go-to motor when I'm making a small robot. I have several of these and I use them all the time. They hit the sweet spot of being pretty good quality without any major downside. They're probably the biggest downside is if you're in contests that are speed related, some people can run faster than these guys. But these, like I say, just for overall general use, this one is the one that I would recommend.
Okay, I've just pasted. I'm going to have to add some more to it, but I'm copying in the thing from your email, Murray.
Oh, yep, thanks.
Yeah.
Okay, and Murray, to kind of break some of your ideas on what belongs where, Scott Gibson's very successful robot is a differential with a big caster in the back. And he goes outdoors and just pretty good job. Right, Scott?
Yeah.
Yeah, that's right. That's
Yeah.
Burp.
I've been working on this new one here lately. I got a video to show if when it comes to my turn. Maybe it won't be such a joke as I thought, but I have for a long time, you know, we all try to come up with a name for our robots, and for a long time I really didn't have a personality to it, but this one I've decided to call Turd for terribly unreliable robot device. So this will probably be the only contest it ever gets in, but and it should be quite entertaining and somewhat functional.
It looks too much like mine for me to be. I'm a little upset about that, Scott. Because if you're thinking it's a turd, then I don't know what mine's going to be.
I thought I had a good name when duct tape and baling wire DTBW, but turd kind of wins over that one. I'm just on the naming alone.
Well, you know, the other one's Burp, so I'm trying to cover all the bodily functions.
I will tell you, my robot got its name just the other day from one of the people I've been in our accelerator group that we've been teaching for the last 12 weeks. They call it Zemo, XMO. And I came up with it. I go, hey, you know, that ain't bad. Kind of cool. Zemo. Everybody else names my stuff. I think that's going to be a trend from now on. I suck at naming. Everybody at code with Harold, you can't name stuff. Don't be naming variables no more. I'm like, okay, well, I'm going to call it something, change to whatever makes you happy. So I'm like, Zemo it is. Cool.
So I think, Scott, if you want to go through what you got, that's cool. And then after that, there's a question in chat. Jason is interested in how to get more traction on a Power Wheels platform. So maybe, Scott, if we go on with yours, then we'll jump to the Power Wheels based
all right.
Rover.
Let me see if I can present this.
You actually have to click inside of the picture of your screen when you're sharing.
All right, hang on, let me get it back up here.
There you go.
There it goes.
You see that?
So
We
right now
got the desktop.
we're just seeing your browser.
You got the screen that's screen and a screen and a screen. So it's your Google Meet screen.
Now let me try this again here.
You probably have multiple monitors.
Yeah. But and I have it like in the just in the Windows player, but it doesn't seem to be coming up as a window.
Usually have best results just trying to share as a screen.
Yeah.
Just to show the whole
Yeah.
screen.
Yeah, but the video is not coming up as a screen though. Is a problem.
Well, just share your entire screen and then just show it on your screen and it should show up.
Hang on a second.
You can't see this window when you're
There we go.
got it right.
There we go. I think yeah, see, it's just not going to show this window. It doesn't look like.
Well, can you highlight that window? Just show it over everything.
Yeah, drag the video onto your main screen and maximize it.
Well, that's what I did, but it's not
Oh.
coming up as a, when I go to present, it's not coming up as a window. Let me do this.
Just do the whole screen.
There you go. Yeah, there you go.
Can you see that now?
We see your background.
The video needs to be over top of the.
Yeah.
Huh, it's really, there you go.
There you go.
That's it. Maximize that sucker and.
Well, see, it won't. There we go. Oh, when I maximize it, it puts it on the other screen.
There it is. There it is.
All right. Finally. So this was a test run just a couple hours ago. And it's certainly not far enough apart. These cones are only maybe 100 feet apart or so. And I don't have any kind of bumper switch. So basically I just kind of walk up to the cone and stop when it gets big enough in the camera.
So I'm not in the contest itself, but I was wondering about the rules on what compromises getting to the cone. When the robot like that one clearly indicates that he saw the cone and went up to it, does it have to actually touch or be within 3 feet or?
There's a point thing. And so like that one where you stop within 10 feet of the cone, he gets 2 points.
Okay.
All right. So if he touched the cone and stopped while he was touching the cone, then he would get 3 points.
Okay, thanks. I just
If he
wanted to
just-
know in
if he
advance
ju-
when I was watching.
But let's say he never stopped. Let's say he just drove by the cone and he got within 10 feet of the cone, but he kept on going. He never stopped. Or he hit the cone and it flew, it kept moving, but he didn't stop. He gets 1 point. So you have, you get a point if you get close. You get a point if you get close and stop. You get a point if you're close and stop and touch the cone. And there's 3 cones.
Yeah, I decided that, getting a bumper switch on there just wasn't worth all the effort. So that's as close as it. Sometimes it'll actually go up and hit the cone depending on what the camera is doing, because basically if the width in the screen of the camera, the blob gets big enough, I stop. So it just kind of depends on how well it's picking up the cone and whether there's reflection from the sun and that sort of thing.
Yeah,
So
well,
sometimes it will run up on the cone, back up and turn around. So
yeah, looks good. I like the way you turned away from the cone. That's something I'm still thinking about how to do that correctly.
yeah, that's a whole behavior in my logic. And basically this is all the ecosystem from Burp. It's all the same code. I just modified it for this different platform. And running it on a Raspberry Pi.
Cool.
Scott, could you say just a few words then about like you're using odometry, GPS, what kind of camera?
Yeah, it's just kind of spare parts. I've got what they call a Nav IO board, which is a piggyback board for the Raspberry Pi, and it's got IMU and a GPS and the servo interface, the RC controller interface on it, and but I found that the IMU on it is very unstable because it's so close to the motor. So I used a BNO 55 as an IMU up here on the top. But I've had issues with it resetting and recalibrating. You really have to be careful about it, especially like if it bumps into something. I presume it's throwing the accelerometers off, and so the yaw change quite a bit. I have but I'm using the GPS from the Nav IO board is about the only thing, that and the RC interface. I've got some sonar sensors in the front, and the obstacle avoidance is kind of rudimentary right now. It will drive around things most of the time, but they sit really low to the ground, and you notice the grass there was really thick. So I have trouble with them triggering off of, grass or, tall weed. And in Burp, I have a tilt mechanism so I can tilt them up and get away from, ground reflections. So I don't have that here. So that's going to be kind of iffy whether that works or not. But I just have a Pixie 2, or actually an original Pixie camera that I had for the blob detection. So it's there's nothing really cutting edge on it. Just parts I had laying around pretty much.
Scott, when you talked about the Nav IO being unstable, being close to the motor, you mean from vibration, or you mean from electrical noise?
I really didn't investigate it too much. Whenever the thing took off running, the IMU just went wacko. And I also had trouble running it on the Pi because the Pi is not deterministic, and the quadrant code that was generating the IMU, because it's basically just a accelerometer, magnetometer device, and they were doing all the Euler angle calculations in software, but since the Pi is not deterministic, the call rate wasn't consistent, so the thing drifted really bad. So that's why I went away from it and started running it on, just basically the BNO 55 that already had software written for and had one laying around. But I can't really calibrate the thing because you can't, it's a little bit big to be rotating around. So I've actually found that just running it in IMU mode, in absolute mode, and just calibrating it to due north when I power it up seems to be as stable as anything that I've used so far.
Yeah, not exactly a resounding endorsement for Nav IO for $168.
No, I would certainly not not go that direction again. And I think the support for NavIO is kind of falling apart. You know, if you're on their website, there's not a whole lot of recent stuff there. I even used a lot of their. I was going to use a lot of their C code because they have examples of how to use the peripherals, and a lot of that didn't work very well. Like the camera interface. Of course, that wasn't the NavIO, but you know, I couldn't get their analog ports to work right. I had a hard time getting their RC servo outputs, the PWM outputs to work correctly. So no, I really wouldn't recommend it. Yeah, I've been kind of looking at the Pixie 4s. They have a whole development eco environment, you know, GPS, IMU interfaces, you know, the hardware cabling and all that fits with the Pixie. They even have a plug-in for Visual Studio's code that you can actually develop in, you know, using Visual Studio's environment and, you know, their IntelliSense and all that. Looks kind of interesting. I don't know if I'll go that route or not, but if you're looking to do something like that, I would look at more something like that than the NavIO. Yeah. So.
Well, cool. Well, Scott, moving robots, even if you're going to call it a turd, that's 3 or 4. We're doing pretty good tonight. Pretty good for moving robots. So that's really good.
Well, at least we know we'll have at least 2 entrants in the contest on Saturday.
Oh, I think it's looking like 6 to 8 actually. So, yeah, we're going to have good participation, I'd say, and quite a wide range of expectations as well. Let's say a good span from hopes to expectations. Good span.
Hey, you know, my bar's low. I do have standards. I just have really low ones.
There's nothing wrong with that.
Carl, it might come down to pent-up frustrations.
You know, there should be an award for that, but I don't know. That could get into trouble too.
Yeah.
Best display of pent-up frustrations. I don't know.
I will tell you, if any of you caught my stream last night, it's recorded. It was a bit salty because I got blocked at every turn and corner and started doing the recursive auger in with versions of stuff and not things. And yeah, I was not happy.
Well, you know, we used to have the last place trophy. I forget what they called it. But you know,
Booby prize.
Spectacular failure, and you probably shouldn't have come with that robot kind of award.
I believe booby prize is what I've heard in my many years of experience in coming in. Never mind.
Hey, call it Bird Blossom.
We used to have an "It Worked at Home" award.
I like that. I got a shirt with that on it.
Yeah, it worked once.
Trust me, it
For
worked.
the software people, it worked when I ran it.
Yeah.
Well, you know that video I showed you was take 6. So what does that tell you?
Yeah, I believe the phrase is "it works on my machine" is how the software world says it these days. It works on my machine.
Well, what I always test them is, well, it worked when I tested it. So
Isn't that the brick award? You know, you put your robot down and it was like a brick.
Yeah, I was wondering, how slow can the robot go for the competition? Is there a time limit?
Yes.
Geologic
I
time.
can't remember what it is. I
like
want
15 minutes, I think.
Yeah, I
Yeah,
remember seeing 15 minutes. I remember seeing 15 minutes.
If every entrant took the time limit, it would be a long afternoon.
How old is the Earth?
Well, if you read the rules, I think that if the judges can start staging them if they
Yeah.
run out of time.
Yeah.
But
Isn't there a rule that if it stops for so many seconds, it's done also?
I think the way it's worded is that if it stops for a certain amount of time, the judge can call it quits. But he, they don't have to. The judge has ultimate flexibility. So, he'd go talk to the guy, and the guy says, yeah, it's dead. I can't do anything with it. And then he'd kill it. But if the guy said, well, give me a few more seconds, it's winding up its eye, it's going to come on here. Because I've seen that, where it just sits there and the eye and the PID just goes, and then boop, 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 it starts moving again. So you have to give them a little bit of time.
Well, who's going to be the judge?
Yeah.
What's the overall things it has to do in 15 minutes? It has to touch the yellow cone, and what else? Go to home and come back, and what else?
There's 3 cones. So in a maximum of 9 points. So in 15 minutes, you would have to get a perfect score. You would have to stop touching each cone for 5 seconds, and then move to the next cone, stop for 5 seconds, move to the next cone, and stop for 5 seconds, and that would be 9 points. And then there's a super challenge, which I'd like to see Bert try for, is where you make no adjustments to the course. The guy hands you the cone, the 3 cone coordinates, and you just, that's the only 3 coordinates you can have in your machine. You can't like waypoint yourself around a ditch or anything like that. You just have to put the 3 way, and then your obstacle avoidance has to handle all the problems that are there. That's really hard. Probably David and Scott are probably the only 2 I know who could do that.
Was there a requirement for it to be a rolling wheel-based robot as opposed to
It has to touch ground all the time. It can't leave the ground.
no requirement for a rolling wheel, right?
Rolling wheel. What do you mean?
As opposed to a 4-legged dog
Oh,
robot.
no, that's fine. Yeah, we'd love to see it. Love to see it.
If I had a drone that was dragging a line, does that consider touching the ground?
No.
Okay. I mean, I don't have one, but I'm just thinking.
Yeah, but we don't want, no drones are allowed. There's too many rules around drones. I was up at the Maker Faire in New York one year, and I actually watched a guy. So I don't know if you've ever been there, but it was a monstrous crowd. I mean, people all over the place, and he's flying a drone in that crowd. I mean, all it would take is that drone to lose control and whack somebody. And if you ever seen anybody cut up with a drone blade, it's pretty quick and pretty weird.
Mythbusters
Lots of blood.
Mythbusters did a thing, and basically they had one of these DJI. I think it's a DJI, but it's a pretty high-powered drone. And they use the human analog to use for this is a pig carcass, because the skin is very similar and all those sorts of things. And they basically showed what happens when this drone gets loose in this thing, and it isn't pretty.
Yeah, we had one at a makerspace. We had one member at the time. He was helping somebody. There was a drone club, and he was helping them. And the guy didn't disconnect or didn't take the propellers off or whatever you're supposed to do. And he left a big gash in his thumb. I mean, it was like that, blood everywhere.
No points for drawing blood.
No.
Out of all your fingers, your blood actually has a vein or enough of a thing in it where if you cut it in the right way, you're gonna get a lot more blood than if you had just poked into your finger or something. How do I know that? I don't know why I know that. But
Kelly, I think, did you have a comment?
Yeah. I've actually got several drones, and the smallest one that runs off a single cell, it'll draw blood, and so DJI drone, it could take the tip of your finger off, at full throttle. So, but actually, what I was going to bring up was I recently designed a modular Rover system for the software guy that didn't want to spend a lot of time or money for a Rover chassis. So I've got a modular design. I'll see if I can share it here. let's see. There we go. Can you see that?
Not yet.
Coming up.
Oh,
All I see is your picture.
okay.
You're getting there.
On another camera, I see something.
Oh, yep. Well, I just have to post a link here and then, but it's a very modular system and everything. It has some 3D printed parts. These parts are very generic and you can use either 3mm screws or number 4 wood screws. And like there's a Raspberry Pi V2 camera holder, sonar holder. There's very generic components and all to it. So if you have a Rover that needs a sonar sensor, this has got a little 3D printer when 3D printable one there that's you can just attach with number 4 screws pretty easily.
So Kelly, that's this one. Is this it looks like it's on a tank chassis. Is this one that you've built or just one that you've seen?
This is one that I built and designed with Fusion 360. And I put all the 3D printable parts on this site, for download. So this is my design. I really like the tank chassis, and I've built some that required a lot of printing, and this one minimizes the printing because it uses little 15 by 15 extrusions. You can slide number 3mm hex nuts into the aluminum rails and attach a sensor anywhere you want. So it's like you could just go nuts with sensors on this design, and the printed parts are very small, so it doesn't take very long to print the yellow parts that are in there. The tank chassis sell for about $8 or $9 and have 2 motors built in. So
that's pretty clever, all in all. So are you planning to bring that to the August thing?
And unfortunately, it doesn't have the range. I looked at how far it'd have to drive, and I estimated I had a range of about 100 meters max and everything. So I'm trying to prepare my Lawnmower Robot, which has 8-inch lawnmower wheels and 4-wheel drive with little gear reduction 12-volt motors. So I've got a much bigger one there that I'm trying to get ready, but I'm not going to have my hardware is not going to be ready until like this next weekend, and that's not going to leave me enough time for software, unfortunately.
Yeah.
But this does have some parts that are very generic and everything. There is I show it with the Intel RealSense camera mounted on it. It's got a standard 1/4-inch screw thread on there, so you can mount almost any camera that's not too heavy with the mount that's shown in that picture. And then there's also a standard Raspberry Pi V2 enclosure too, that all the parts are interchangeable. So
that does look pretty clever. It'd still be, if you were planning to come in person, it'd be great if you could bring it along. I know at least one person would like to see it.
Yeah.
Looks really interesting.
Even if you don't plan to run it in the contest, just bring it out for display and share ideas. We'd love to see it.
Yeah, that sounds like fun.
For sure. Yeah. It goes for everybody, by the way. I plan to bring some that won't really run.
Yeah, show and tell sounds a lot less challenging and all that.
Yeah, absolutely.
Yeah.
It'd be great. Well, thank you, Kelly. That's pretty cool. That's a really nice looking robot there. Be interesting to see more about it later. See what it can do, for example. All right. Who would like to show something next? Anyone? Oh my, we're drying up early.
I can show my Spot Micro build if you have nothing else to No one else?
All I got is a bunch of whining, so it's not going to do anybody a lot of good. So.
Oh boy.
I've got a small update.
Well, let's go. I think Glenn has something, and then I think Pat, that was you. And I have a small update too, but
I've got a question too.
okay. So we've got a whole bunch. So Glenn, Pat, Kareem, Carl. How's that? Glenn, take it away.
Okay, so the project that I'm currently building is the Spot Micro Robot Dog, and I can walk you through the build of it. It's currently in pieces. I just really finished printing all of the parts for it, and I'll walk through some of the challenges with it. Let me show you some of the websites. This is the head that I just took off, and the tail. You could put a LCD display in the tail, and there's one of the. These are. It takes 12 99.6 servos, and there's 4 legs, each with three of the 996 servos in them, and in the middle will go a Jetson Nano. You can get these at SparkFun for $99. The 2 gigabyte version fits right in the middle of the body of it, next to the PCA 9685 servo controller in that, and there'll be a battery that goes in the bottom that will hopefully power everything. The head has 2 ultrasonic SRO4s in there. With this, I'll show you the website for the camera, and I do think this looks like it is a HDR camera. It's the Sony IMX219, and I'll open up the website for it. But it will go right here on the. There's an extra little 3D part that I had to print from someone else to mount the camera in, and when it's done, there'll be the 2 ultrasonic sensors with 4 infrared LEDs, and then the camera will be in the middle. So that will be the head, and the legs. The legs here, as you can see, have. Let me show you the other leg. The legs, there's obviously a servo here that will hold it to the body, and then a one servo here in that joint, and then another servo in that joint. And these were quite challenging to print. I had to reprint them like 3 times, a lot of them, until I figured out the best way to print and the best material, like PETG rather than just PLA. Because of the strength of these parts, break easy if you don't print them a certain way. So let me first show you the genesis of the project. Oh, just a minute. It looks like I didn't have screen sharing preferences turned on. Let me try again. Oh. Give me a quick second. I'll quickly try to get my screen sharing permissions on.
Looks like Zoom works a lot better than this tool.
I don't know. I found issues with all of them, pros and cons.
Yeah, today the team I'm on that I'm assigned to at work, they've chosen Slack as their communication choice for our team chat, and it crashed 3 times in less than 2 minutes on me trying to bring up the Slack video. So just don't do Slack video, or at least it didn't work out for me, and I've got some pretty good hardware.
I guess it was muted. Can everybody see the screen share now?
Yeah.
Okay, great. So the home page of the Spot Micro. This is what it this is one build looks like the robot dog, and the Boston Dynamics robot dog is uh, the $80,000 robot from Boston Dynamics is sort of the mother robot that this is modeled after, right? And this build is on Thingiverse at if you go from the original Dong Young Kim, the build that I'm building from is his Thingiverse model here, and so this is the Thingiverse version model of it, and I'll be using the Jetson 2 gig developer kit board, and I'll have this Sony IMX 2119 camera that I showed you will be the camera module in the front. It looks, it can do pretty high resolution, pretty wide FOV, and so it might be a camera you might want to try out in your robots. Although I don't know how well it would do on a, you would at least, I don't know if it would work on a Raspberry Pi even. I mean, it's designed for the NVIDIA, so I don't think it would be usable, or I don't think it supported, the Raspberry Pi supports it. But anyway, the robot itself, the build of it was quite challenging. I had to figure out the best way to print, for example, the head. If you don't print it standing up, then I wanted to both get a sturdy build as well as some some. I wanted to make it shiny. I wanted to make it at least look nice. So I didn't want the raft or the bed to mar the surface of the head. So you had to figure out the best way to print the parts, so you can see that it comes out with a lot of support that way. But the legs also, I kept printing them. These legs look okay. So the leg, those shells go on the leg here, and they kept breaking every time I would try to put them together. You have the 996 servo here, and they kind of snap fit in place. They have a ball bearing, a roller ball bearing, common ball bearing on the front, and they kind of snap in place, and then there's some screws. And so if you don't get that printed right, they tend to, that these things kept snapping in half. So I had to finally print them like this, and I was able to get them printed.
What material are you using?
This was actually just a PLA, but I started printing. I just got some black. That for the black, the yellow is really just a shell, although it provides a little bit of support. For the black, I am using PETG for the black leg part, the part that needs sturdy here. These parts, the legs, I wanted to get them really sturdy. I printed them with PETG at either about 50% or greater infill to really get some real sturdy legs out of that. And then they kind of, let me show you, to get the legs really sturdy. They're pretty sturdy, and I like the way they're pretty sturdy, and they snap together, but they have plenty of screws that are kind of tricky to figure out. You have a screw there, but you got to get the right order of the screws for the servos. I don't know if you could see them from the picture, but you got to get the screws in, and then put the servo and snap the plastic around it and still get the ball bearing on it. And then getting the last piece in was tricky to get that in. And then the issue that I'm working out with the joint mounted on the body is I need to make sure there's a gap between the body and where this servo mounts into the chassis, and I have to grind down a little bit of the plastic on the inside to get the servo horn so that there's not a gap, because I want this servo to be seated really well in this in order for it to not, the leg to not pop out. If the leg pops out, then it's gonna either break or I want it to be really sturdy to walk on all four legs, because there'll be a lot of stresses on it.
It's
So
gonna be a dislocated shoulder, huh?
yeah, it'll be a dislocated shoulder. So that's my challenge right now, is making sure that I can get this these servos seated so that I don't have dislocated shoulders, and then still need to be able to take the thing apart if needed to put the electronics, or maintain or fix the electronics in there. There'll be, like I said, an LCD display and a stop button on the front. I might use a micro LCD display, and then the head electronics on it. Today I just printed the chassis for the Nano board, for the Jetson board, to house both the Jetson on it, and then the little PCA 9685 will sit next to it in the middle of the board, because the stands for the board broke off my other print. So I printed this in PETG with a lot thicker supports, and so that this doesn't fall out of the robot or fall off while he's moving around.
What size print area do you have?
I have a Jagara, if I'm pronouncing that right, which I don't recommend to anybody. I do use I don't know if I have a photo. Oh, I do have a photo, probably. It's a Jagara. I would recommend a Creality, actually, Creately. But this one's from Japan, right? It supports. So I don't recommend. The Creality. I mean, the Jagara printer.
Do you have an application in mind for this robot dog, or are you just goof around and experiment?
Mostly goof around and experiment with it. I mean, the application would be to experiment with machine learning on it, and human AI recognition, and put some TensorFlow and PyTorch AI machine learning on it. So that's my real goal, is to put some real world machine learning with TensorFlow and image and vision recognition in it, is the ultimate goal, so that it walks around and recognizes people and speech and sounds, and vision recognition ultimately. But I'll work on one little piece at a time to get it right. I have kind of a certifications degree, almost a degree in machine learning. So I'm going to put either some TensorFlow or some PyTorch development on it and do that. I'm working on these are rare. My printer, just to answer your question, it's fairly large. What is that? The 220 millimeter bed by per square bed Jagara printer. Somewhere I have the big picture of the printer, but I'm also working on the I've kind of have it in pieces behind me, but I'm also working on the move robot. Has everyone heard of the move robot?
Not yet.
The move robot, I have it behind me. I can pull it out off my shelf, but it's kind of in pieces. Let me just show you what it is first. Gail Lebanon, he's French. Legivin was the original builder of the move robot, and it looks like this. Is the robot full size? I've printed the head and the right arm without the shoulder. I have it in pieces. I have it in various pieces around here in my office. I have the head over here, but the head will have Raspberry Pi in it. You can see it has a couple servos in the top and in the mouth, but the eyes will have a either a single or a dual Raspberry Pi camera pair in the front, and the mouth is activated with a servo sticking down here in the middle, and the mouth talks, and so you could tie it up to speech recognition or have it talk whatever you want from the internet eventually. So that would be something to do with it. Would be to just have it kind of recognize people and move its hand. I'm printing the hand. I've just printed one of the hands, the arm, and he's got 5996 servos in the hand. If I could show you close up of the hand somewhere. Well, let me see if this picture has. I could show you from the build of it. If you go to the build and go to the hand, you could see really good pictures of how it's built. Or there's a video, but you could see there's there's 5 servos in the hand that pull like this heavy fishing line in the fingers, and I've got all the parts. You can see how it pulls it's strung to all the fingers in there, and so quite a challenge to print though too, because I was printing it all in PLA, and I'd recommend you print it in PETG or ABS instead, because I had to reprint most everything like twice the way I was printing it to figure out the best print infill and everything to get it printed, because otherwise it keeps falling apart when I build it. But the original builder, he is a modeler, and originally what happened was he was contracted to build a prosthetic hand, and they didn't continue with his contract or something, and he decided just to continue building it and then build an entire robot. So it's actually modeled after the original builder there, Gale, and so he shows it off at a lot of all the big maker, or had showed it off at all the big maker fairs, and you can go in here and watch the videos of the robot on the YouTube channel. And here's an example of it talking, I guess. Come closer. Okay. Yes.
That's an awful lot of servos.
Yeah, it's quite a bit of servos. That's why I'm just working on the head and the hand right now to get that right. Tell me if you want me to stop for time's sake.
Okay. Rest. Well, so are you planning to build this whole thing, Glenn?
No, right now my focus is just on the head. And let me stop sharing for a minute and I'll show you. So I can put all this in I could put a lot of these links in the chat. My focus right now is just to get the head built and the hand and the arm, because it took me quite a while to print all of the hand and pieces and parts and then reprint everything. A lot of the pieces 2 or 3 times. I have the head in a box and the parts in a box. I put it down for a bit and haven't gotten back to it. But the reason why I had to reprint it a lot is because Gail, the inventor or original designer there, uses a lot of the servos from based out of Hobby King from England. And to get the cheaper servos, because it does use a lot of servos, so to use the cheaper 996 or more common servos that are available cheaper on Amazon, some of the parts have to be redesigned, and it's a lot of head structure to do that. So, question?
No, a couple people are dipping off, which happens sometimes, but that's okay.
I had a question. Was there? I might have missed this. Is there a projected cost to build one of those things? Like, how much is it? Like, any idea?
Yeah, I mean, well, on the way, it really depends on how, right on. I mean, obviously, I don't think it's accurate. I mean, if you reprint it, obviously, you got your cost of the plastic, and the real cost, I guess, is the servos and really how much you spend on the electronics and what kind of tablet you use, because he uses Robot Lab, and you might want to add a Google tablet to the back of to it, and maybe either a Windows computer or a Linux, some other, maybe not just a Raspberry Pi. It depends on what you build it with, right? Some people are around the world are just using it to print the hand, to play with the prosthetics part of it, and they don't care about the rest of the robot. I'm more interested in the vision and the head and the hand, and maybe, just letting something show the basic interaction between recognizing voice and vision and moving the hand in response to a command. That's all I'm interested in. But he actually this past year printed the legs, designed the legs, and so he's working on making the thing walk. But there's quite a lot to make it do that. As far as the cost, though, yeah, I mean, conceptually, if you could download all the STLs and somehow measure the volume of all the STLs, you can get the amount of plastic, and then add up the cost on a spreadsheet of all the servos. But you're going to run in the neighborhood of a couple $1,000s eventually, probably, because the servos I can get only 4 of them for like under $30, right? And you need 5 of them just for the hand alone, and you need another 4 or 5 for the arm and the thing, and then you need 3 in the head, and then and that's just for one arm, right? You got
So nobody's actually gone to the trouble of costing out the whole project yet. There's not been a projection of that.
They mentioned some money in here. I don't know. Remember, it's been a while since I've looked at how much. I don't think it's been a detailed cost, because different people have built different. I mean, I don't know if I've seen the cost in there. It depends on what you add to it. In terms
Sure.
of
Oh yeah. Yeah. Like I'm looking at a Mars rover. I live in New Zealand, and because of shipping costs and the cost of things being more expensive, I'm looking at just a standard small Mars rover costing like $3,000 here. So
the shopping thing shows the right-hand V1 looks like mechanics, just plastics only, no servos, 108 euros.
Murray, are you thinking of buying a 3D printer?
No. I'm probably going to build everything out of Go Builda stuff. No, I'm not. I'm not succumbed to the cult
Not
just
yet.
yet.
Huh? Not yet.
Now, Glenn, there's been this ongoing joke that everybody that I ever talk to about robotics nowadays wants me to join the 3D printing cult.
Come on, Murray, get the particles in your vein. You know, come on, come over to the PLA side. Just saying.
Lynn, just my advice, just throw away all your other filament and only print with PETG. That's what I do. I gave up on PLA and ABS for all sorts of reasons.
Yeah, you know, I think I'm headed in that direction. I recently actually, just because of this Spot Micro project, got the PETG because it's been so frustrating to print these legs and they just keep breaking every single time. Even the PLA of the structure would just, I'd go to put the servos in there and it would just crack in half. And then I tried to print them in different orientations to get the strength correct, and it was just driving me crazy. And then finally with the PETG, I was able to print it. And ABS, okay. I mean, ABS plastic is a little more expensive, and you know, if you don't get the temperature in the bed right, it's messy. And so, yeah, I mean, I am now a fan of PETG definitely, and I don't see any reason other than if there's a cheaper PLA and you're just printing little boxes and parts and things, use the cheapest PLA you got. But for stuff you need strength, you need at least the PETG.
Here's a question out of ignorance. We've kind of broached this before, but what would it be to print it out of nylon?
Oh, it's just more expensive. Nylon's more expensive. I think way more expensive. I think,
and way harder to print. It's slick as all get out, and you got to get the bed extra hot, and a whole bunch of other things. I've never tried to print it. I've seen people try to print it. I've been looking at it. Most people do not have the capability of printing nylon.
See, Harold, the whole thing for me is that if I was going to bother to print in 3D, I think I'd only print in nylon.
The biggest thing.
I'm not surprised by that, Murray. You tend to go big or go home, which is awesome.
Yeah, probably the biggest problem, Murray, is the fact that it's it absorbs water, and then when it absorbs water, it sputters when it's being heated. So you get it's not a fun thing to print. It's kind of messy. But if it's dry, in your machine, it's got all metal extruder, and your bed, and this is a big if, can get up to the right temperature. And there are special beds for nylon. And if you have all that set together, you can print it. It does help to keep your parts simple. You want to say simple, you don't want...
I print gears with PETG, but I know the preferred plastic for gears would be nylon. If you could.
Yeah. Well, the nice thing about nylon is that, and I even think so. There's several plastics that they actually, the layers bond. They become one. Do you know what I'm saying? You might still have striping on the outside, but the lamination between layers is pretty null. But if you can keep it dry, it is a little more expensive, but one roll of nylon will last you a long time. The problem is keeping it dry between uses. If you were trying to do something and you're going to use it all up, and you're going to run it 24 hours a day until it ran out. But if you're going to cut one part and then maybe the next part's going to be 4 months away, it's hard keeping it dry.
Well, I mean, what you would do is print your first prototype in the really cheap plastic, and then something final, go ahead and print it in nylon. But what you really might want to do, of course, it's double the price of nylon or more, is carbon fiber. So if you really need some strength, you want to spend some of the big bucks and get the carbon fiber. But
I was just more the thing with this is an ongoing conversation about 3D printing, but every time I hear about 3D printing, it's sort of like all these trials about which angle to print at and all that. And it seems like if I was going to go to to go to the trouble of buying a 3D printer, which would be more expensive because of the temperature and all that, I don't think I could be bothered with all the difficulties that people have with 3D printing unless I was gonna simply, and like you said, Glenn, maybe for the prototypes, print in a cheaper plastic. But if I'm gonna build a robot that's gonna cost me several $1,000s, I don't want the legs breaking. You know, I just have too much trouble.
Right with you. I've actually have several thousand probably hours of 3D printing. I teach 3D printing, introduce people to 3D printing as an adjunct instructor at the local college here in Maryland, Frederick Community College, and I've printed thousands of hours and thousands of all these different parts. And yes, I just sometimes shakes my head. Why did I spend so much time trying to print these parts? Because like I said, I printed the in-move head at least twice, and all the fingers and the hand and the entire spot micro just to get the orientation and the infill and everything right. And on the website, they don't really document what they've printed out all the time. So you kind of have to experimentally figure things out, is what I found. And everything is just breaking when I don't print it right. It's just.
By the way, I just did a Google search on in-move robot cost. It says, and one site lists $1,500.
Oh, okay.
Man, I wish I could do that in New Zealand. It'd be impossible.
Why?
Well, just the cost of everything here, import costs, shipping costs. Like I put one order in for this kind of stuff from Servo City, and I bought this and a few other things, and it was like about $250 of parts, which in New Zealand dollars is like $350, and then we added another $150 in shipping. So
how does it work on Amazon Prime for you? You
there's a lot of things they won't ship here.
Really?
They won't ship electronics here.
Really? Wow.
No, I live in a small country a long way from everybody else, so it's just goes with the territory. I could leave the country and catch COVID, so I have to choose, right?
Wow, I never realized that. I knew y'all are way out New Zealand, but
we're as far as you can get from you guys. I got on a boat and I just came out here, and I'm like a million miles away. So,
oh, wow.
But Harold, I just realized you found your high priest. Glenn is the high priest of 3D printing.
Yeah, I can pretty much have a lot of expertise in 3D printing.
That's cool to have you along.
Oh,
welcome to the group.
Yeah, if you have any 3D printing questions, I can get them answered one way or the other if I don't know them off the top of my head.
Oh, there's so many rabbit holes to go get lost in.
Yeah, I was actually looking. There was a YouTube video a few years ago that they took a motor, like about a 15-horse motor, and they printed with different props, all the same prop, but they printed nylon, carbon fiber, and a few other things, standard PLA, PETG, those sorts of things, and they all ran through both a in the bucket on a land test and a real world, can this push a boat and how far can it push it? And what it turned out, whatever from memory serves, they all were betting on the nylon to win, and it didn't. Something else won, but the other thing they pointed out is the carbon fiber. It is strong, but it's not like the carbon fiber you would think that airplanes are made out of. Those are actually, the carbon fiber is short little fibers, not the big long string thing that gives carbon fiber its extra crazy strength, right?
Well, yeah, you see, that's the thing. I mean, the 3D printer is just laying down the filament in rows, right? And you've got that shear strength that's going to be your problem. And so you're constantly orientating the part against the shear strength so that it doesn't break against the shear strength directly. So that's kind of the challenge on a leg, where you put the stresses on the leg. You want the stress to be perpendicular to the shear strength of the leg. So yeah, all that matters, very, very much so.
Well, so far,
having said that, on the 3D printers, I think there was, at least for a while, there was one 3D printer that actually would take a single filament of carbon fiber and lay it down in a substrate of epoxy. So you could actually, it wasn't like a woven 3D fabric, but you could lay down long fibers.
If you want to spend about $5,000 to get started, Mark Forge makes a very, very nice printer. It's a dual extrusion printer that not only does it lay down their Nylon X special extra strong thing they formulated, but the second nozzle is printing out a continuous run of fiberglass to embed that inside the plastic as you're doing the other stuff. And Ducati uses these things to make replacement braces for some of their motorcycles. That's how strong this can be after they do some annealing and other things to it. Pretty amazing. But I got $5,000 laying around, so
that would be great because I've thought about, okay, I could heat up a piece of metal and, with a soldering iron and stick it through a piece of plastic. But if the 3D printer could lay down, a rod in between its print, it could put like concrete reinforcement does.
Yeah.
Rods in the concrete. If it could lay down a rod after it prints a while, that would be great. But I haven't seen any printer that does that. Or you could add a little robot to it that sticks the rod or somehow on the thing and melts it through. But the best you can do is change the print settings before you print the profile to change the infill from hexagon or fast hexagon to just rectangular, or you'd have to figure out what kind of infill or try out different infill might work for the strength of material of the part you're using. So that's another way to work with the profile. There's 1,000 different settings you can set it for.
I don't mean to really change the subject here, but Kelly, you were saying, I saw in chat, you're saying the ExoMi looks like an interesting project. I can tell you by personal experience, it is. That's what I have sitting in front of me right now on my desktop. And I'll be bringing it to the things so you can show it off. It's a really great robot. It's a really great platform. My problems is I'm trying to take it further than it was originally designed, and I'm running into versioning of Python, and that's why I didn't want to get on here and whine too much, because I can do nothing but whine, because I am in recursive version hell to find all the stuff and get all the pieces working to make it do what I want to do. So, yeah, it's a neat thing.
Carl, didn't we have people waiting in line to whine?
Yeah, I was trying to, we lost Kareem at least, but I think, Pat, were you next?
Yes, please, Pat, come on.
Yeah, I've got a small update, not very much. So you guys have seen these things? USB or USB to SSD adapters. Plug in to get a little hard drive going on your Raspberry Pi or your Nano. So I had one that sporadically, just managed to track it down yesterday, is disconnecting the hard drive. So we're in the middle of a run. So I found that out. I was in the middle of compiling something, and all of a sudden it would crap out. Okay, reboot it, start everything back up. Worked great for the day, start compiling at night, and walk away, and same thing, it would crap out. So eventually to find out, okay, let's try a different one, and it worked. So these little things you buy for $15 on Amazon sometimes aren't the best. So I've got another one coming. It's hard to find them with short cables. So I'm going to see what I can do with that. The other one is I have a
driver for it.
Pardon me?
What about the software for it, the driver? What driver do you use to recognize the drive from the Pi?
It's automatically, it's built in. It
Hey,
just
Pat,
works.
This one's an inexpensive one that works. I can, I'll link you the one I purchased, because you're right. I have another one that doesn't work. Okay,
Yeah.
so I mean, I was trying to find, there's a big trick with these Raspberry Pis. The first hurdle to get you to boot up is it has to be able to create a sector of 512. All right, because the Raspberry Pi will only accept a 512 or a 1024. And a lot of them will only do 4096 as the smallest. That's the reason why these little tiny drives, I don't know if I've got one around here. Ones that look like this. This one works, okay? But I said, wow, and I got it first out of the box and it worked. And I said, man, that's great. They're really cute and they fit real nice. But I found out, I went and bought 2 or 3 other ones, and their controller they're using in a lot of them, like I say, the smallest sector you can have is 4096, and that will not boot up on a Pi. It'll be fine for additional storage, but if you want to eliminate the SD card, it has to be you have to have a sector of 512.
Yep.
And
That-
when
that's
buying from Amazon, the secret is ignore the positive reviews, always look for the negative reviews, and look for the specifics of what they're saying. Please post a negative review about that adapter so to help us out.
Yeah, exactly. So like you say, I went through a few to get some that are working, and it was working well. It just sporadically out of nowhere, it just craps out and disconnects the drive. So it's not like on boot up. This is after hours of running. And so I've just switched over. The one I've got right now is a Saberent, and it seems to be working really well. But it's got a 2-foot cable on it, which is a little long for what I need.
I just put a link in, Pat. I used this easy laptop install kit for a computer, and it's a really short little cable, and it worked well enough.
Okay.
I could swear I've seen it for $17 when you buy the drive, but it looks expensive when you buy this whole kit like that.
Okay. And then I just posted a link as well in the chat. And that's for a little application I got for Raspberry Pi for images, disk images. And it's called Pi Shrink. So it'll take my 128 gigabyte hard drive, the SSD I've got, and it'll shrink it down to get rid of all the blank space on the drives. You can actually compress the image if you want as well. But I just basically shrink it down to get rid of the empty space. And now I can store that image to be restored or as a backup for, maybe 8 or 10 gig instead of 128. So it's pretty good. It's a handy little routine.
That sounds useful.
Yeah. And then the other one, just an update on my robot for the contest. Along with the failure on with the hard drive adapter, I have a problem with latency and communication. So all of my routines work phenomenally with 1 or 2 or 3 routines working. But when I put all the routines together, I get a huge lag in communication speed between everything. So I've tried a couple different things right now, and I'm going to be, I don't know, I'll try a couple of others to see what I can do. So 2 of the routines are serial through USB. So one of them is to my ultrasonics, and one of them is to my motor driver. And I'm doing it every 50 milliseconds at 115 kilobaud. I think I'm going to drop that down substantially to give it a test, but I've got to figure out where my problem's coming from, and I'm not 100% sure that it's from the communication in the motors or the ultrasonics. I think it's something else in Python that's giving me trouble. I was using MQTT, and I've tried now Python Q to try to communicate between Python and multiprocessing. So I converted everything over to multiprocessing and started with Python Q. But I get about a 30-second lag on results, which is huge. Where originally this was like instantaneous. So something is, I don't know if it was my hard drive adapter that was giving me trouble, having to try to reread all the time. But I'm waiting on another adapter to come in, and then I'll see what I can do to speed up communication, because 30 seconds is way too much lag time.
Hey Pat.
Yep.
I can't remember which one, but at one time, Chris, you know who Chris is, right?
Yep.
He did a deep dive into how to to make your pie essentially almost real time. And it had several. I remember it had several priority changes. You essentially dedicate one core, and a whole bunch of other things that he went over. Now, where it is in this is one of the problems with meeting every week is we finding that sort of stuff. But you might be able to scan through some of the chat records and see if there's any kind of pinpoint when he was talking about it. Or you could wait until next week, but that's kind of late for your contest. Or you might reach out to Chris. I'm not sure. Carl, do you have Chris's email or anything?
Yeah, I don't know offhand. You might be able to find.
The other thing you can do is if you just Google on how to install a real-time operating system on a Pi, that's not hard to find. That kind of stuff's out there.
Yeah.
I mean, on the other hand, I have been actually working in Python 3 or CPython on a Pi, and while I do agree that it's not real-time OS, I am not having that many difficulties. Like I'm literally right now over here. I don't know if it's actually running, but this is actually running. Let's see. Oh, I need to actually turn it on. Sorry. I'll start it up. This is my motor. I get to get my gold star for the day. This is actually, oh, there. Okay. There. I had this. That's actually a real-time operating system on a Pi PID controller. And you can see it slows down nice and slow. And I can even grab the wheels. So that's my PID controller running on my robot in a Python-based message bus, asynchronous message bus, and that's taken me months to get to that point. But it does actually function, and that's on a Pi without the real-time operating system. And the one thing about turning your Pi into an RTOS is that you no longer have a Pi. So there are things that are meant to run on Linux that are no longer running. So you do have a lot of side effects. So you have to, if you're turning your Pi into a microcontroller, which is what you're trying to do, you lose the fact that it's a Linux OS and you lose some of that functionality. So you have to be kind of careful about what you ask for there.
Pat, Chris is a member, and he can be reached on the list if you want to. Just say,
Yeah,
hey,
maybe I'll reach out to him on the list.
Yeah, it's Chris Netter is the name.
Okay. I will. I'll look him up on the member list.
Okay.
And send out I'll send out an email on the list.
Mm-hmm.
Actually, I have his email, Pat. I can send it to you. I don't know if I have yours.
Don't say it out loud.
You have mine. You have mine, Carl.
Oh, that's right. I mailed to you. Okay, I'll get you his. I'll get you his in a moment or two.
And again, if you search on RTOS Raspberry Pi compile kernel, you'll find lots and lots of stuff. Lots of people have done this actually. If you can't get in touch with Chris, but you know you just compile the kernel.
Kelly was asking if I was running MQQT on Rover's Pi. Yes, I was. So I was running a Mosquito broker on the Pi itself. But looking at the routines, it's about 300 every 50 milliseconds from several routines. So it's 200 to 300 messages per second is what's going through. So if I'm getting updates from the motors, I'm getting updates from the ultrasonics, that sort of thing.
Yeah.
It tends to pick up a lot of messages. So I think some of that I was going to try to clean up. And
yeah, you might consider some special modes like a driving mode where messages that are relevant to collisions and things like that are going through the message queue and just kind of cut out the unnecessary stuff depending on what type of mode you're in.
Yeah, so one of them I was looking at is like just my motor controller. Do I need to be talking to it every 50 milliseconds, or can I live with 4 messages a second?
Well, Pat, what actually I'm doing with
I would typically with microprocessor robots, everybody's running around 20 milliseconds. Now 50 milliseconds or 40, I've heard some of them running on 40. So, that's probably on the high end, but 4 times a second might be a little bit,
Yeah,
a
so
little bit slow.
trying to figure out where I can save some time. But
Yeah.
there's something else in Linux that is slowing me down. It's I don't think it's the routines, because when I run them individually, everything is running good.
Mm.
So if I run my navigation routine with with just my motors, everything is good.
Yeah.
As I
Taking it
introduce
to,
as I introduce other things, I start seeing more and more lag into it.
Well,
taking
Pat,
it to
what I've
one
been doing,
one core might be, dedicating one core just to that might help that out. And changing some of your priorities too might help that out.
Yeah,
well,
I
Pat,
haven't
one of the
tried,
things that, go ahead.
I haven't tried changing priorities.
Well, one of the things that I've been doing is that I'm using a message bus with and all the messages have an event type. And so the messages coming through from sensors are different than the messages coming through for motor control. And so I've got a publish subscribe model. So the motor controller is subscribing only to messages that pertain to motor control. And so basically there's an inherent filtering in what listens for what. And so my subscriber for the motor control only gets a few of the messages and ignores all the sensor messages. So
Yeah, and that's what I think is happening. So my arbitrator is listening to everybody. And I think it's the arbitrator that is tending to knock everything down. I've got a routine, and it's on message received. So I receive a message, I basically jump to the routine, find out who's sending the info, store the info, and jump back out and carry on. But
I had that very similar situation. I have an arbitrator in mind, and if I prioritize messages using the arbitrator, that means that the high priority messages are getting through, and the ones that aren't as high priority don't get through at all. And I found out that I just had to pull the arbitrator out of my architecture entirely, because it's a public, it's message bus with publish and subscribe, and so if I have an arbitrator in there and some of the messages that are meant to be lower priority are being arbitrated out of existence, they never get there.
Yeah,
it sounds like what's happening to you.
It's when I'm watching it, trying to troubleshoot it, and as soon as you start printing things, displaying to the screen, you start slowing everything down as well. So you can only print so fast, and it's waiting for a print to finish. So when you're looking at a couple different routines, that's one thing. But once you start adding all the routines, I have to turn the screen prints off. So I turn my troubleshooting off. I'm not logging it to a file right now, but I'm still seeing a delay, a backup.
And you're running at 50 milliseconds?
I'm running, yeah. So I scan my routine every 50 milliseconds.
Yeah, that's what I'm doing. Yeah. Okay.
Have you looked at, switching boards to like the Renesas ARM Cortex MCU boards, multi-core boards, or are you stuck on using the Raspberry Pi?
So, well, contest is in less than 2 weeks. I'm stuck to using a Raspberry Pi. One way or another, I'm going to have a robot out on a field, and it's going to do whatever it can to try to reach at least a cone.
Okay.
Pat wants his cup.
I want my cup.
Oh, you get a cup? You get like a trophy cup or something?
Yep, exactly. Yeah. So
Canadians aren't at all competitive.
No, exactly.
Speaking as one.
It's not the Stanley Cup, but hey. So that's about it for me. So
that's pretty cool. We all had our little setbacks along the way, and we're making progress nonetheless. So,
well, I found a whole bunch of different ways not to do it.
It worked for Edison.
Exactly.
Well, I've got a new question, and I've got a Rover with 4 motors, and I was interested in using some L293Ns, which can handle 2 motors each. And I was curious why, or if it's possible to connect the L293Ns into a servo controller, since they're both PWM devices. Has anybody ever hooked L293s into servo controllers? I mean, you'd have to use 2 servo channels for one 293 since it's a 2 motor, but
all that should work. I use the the SparkFun motor controllers, but yeah, you just need to use them for all the coils. You know, 2 are going to be used for 1, but all those should work fine to do it for servos.
Mm. Some of those servo controllers can do like 16 servos, which it could be like 8 motors and 8 steering servos, which you can do some pretty interesting things with
Well,
16.
yeah, the challenge is really the power because,
Mhm.
you know, with the start and the stop, they could affect the signals and the other servos, and so the
Yeah.
crosstalk and the power is where you get into trouble.
Yeah, yeah. The 293s do have external power, but some of the servo controller boards, like the Adafruit, do have a 6-volt input that you can boost the power and all. But I was just curious if the PMWs were compatible.
Keep in mind there is different. Are you using Arduino or Raspberry?
Well, my main single board computer actually is an NVIDIA Jetson, which does not have good support for PMW. So I was looking at some of the servo I2C servo driver boards, and then I had some 293Ns. So I was kind of thinking, well, maybe I could use those. You know, if I make a little wiring harness, I can run 2 servo channels into a 293 for 2 motors. And
Yeah, well, I mean, the popular thing to use, like on this robot dog, is the PCA 9685. It's a 12-volt, 12-channel servo driver with an F-Copter board to use. You can get it at Adafruit, and you know, I haven't tested it out very much yet, but I have a few of them to put on some other mobile robots too. But it's kind of the thing that everybody kinds of use for Raspberry Pis and Jetsons.
Yeah, I've written code for the 9685.
Yeah, I've got some of the 9685s too that I've used quite a bit. I just never have tried to connect a 293 motor controller PMW device into a servo controller.
I don't
I'm a
think
little,
you can do that.
I'm a little confused,
I am
Kelly, because
Yeah, I don't think you can do that.
yeah.
Yeah, servo is a PMW device, and a 293 is a PMW device. So it's kind of
Yeah, but the servos have a very specific. It's a PWM with a pulse width at most of 20 milliseconds, and you vary the pulse width to control the position of the servo. The motor driver you're talking about wants a PWM signal to control the speed, and it's going to be it's completely different range of PWM frequencies.
Okay, that's what I was kind of suspected, you know, because I haven't seen anybody do it. So I didn't know the
It's
reason.
not. Yeah, it's not something you can do directly like that.
Okay.
Keep in mind, even the Arduino has 2 or 3 different frequencies used for its servo PWM pulse output. You know, pins 9, 10, 11 has one frequency, and the other pins have a different frequency. So keep in mind they do multiple frequencies.
Yeah, but there is flexibility in the frequency. You're correct that Arduino only uses a certain set of them, but it can be adjusted. I mean, it's just an AVR chip. Well, I guess it's a microchip now, but you know what I'm saying. It's there. You can go into the registers and change that up. Yeah. So that would be if instead of doing it on your Nano, you probably want a microprocessor, and to talk to the microprocessor over I2C or serial, but I2C would probably be more conventional. And just so your Nano is only using I2C bus, and it's driving supporting microprocessor, and you're using its PWM pins to do the job.
Yeah, thanks.
Okay, cool. Well, we've lost a handful of people, but I'm not sure everyone that's wanted to has been able to give an update yet. So to be respectful of time remaining, so did anyone want to walk through and share an update of anything? Okay. Unless we wanted to hear Harold gripe or me gripe, but
I got plenty of wine. I got plenty of cheese to go with the wine. How much do you want?
If that's an open door, you give a short gripe, I'll give my dismal display of progress, and then we can call it a night.
So where I got sideways is that I need Ross is putting out my image in an array of ints, right? Cool. However, if I use Python, that array of ints comes across as one big old string, and then I have to convert that string into an array of ints, then get those ints into a way where I can send that into a Docker container that has my image recognizer that really works really well, by the way. The problem is I was unable to make that happen in any way, shape, or form. So I'm like, okay, the C++ version gives me my array ints. I got in, did that, made it happen, get my array ints, happy. Now I need to make a HTTP call with C++. And I'm like, you're going to say, well, just do this. Well, I just did the most popular thing I could find on the net, and it says, oh, you just add these lines into your CMake list file, list.txt file, so the Ross will do all the things and get all the stuff added in the library. Sure, the library says blah. No, I don't know that command. So I went and looked at the command, and it says anything with CMake above 3.11 or greater has this command in it. So cool, let's go see what I've got on mine. Ooh, I've got 3.10 and some change. And I'm like, well, okay, how do I upgrade that? Well, you can't, because I'm actually running on Ubuntu 18 point something on the thing, and that's the most recent version of the package that's on there. And so the next thing I do, well, how about if I just grab the code and I start compiling it and do it myself? And I said, nope, I'm out. So everything I tried in the last 2 or 3 sprints to make this happen has ended with a version mismatch, whether it's Python, because I've got 2.7, 2.6.9, and 3.7 running all in weird Docker container configs, and I'm just trying to cobble it all together, and I've just run out of cobble. So that's about I can keep on whining if you want to listen, but that's about the gist of it.
So getting back to the beginning of your conversation, you said you had an array that you were trying to break into individual ints.
Well, I get that. That works under C++. The problem is the Python makes a really great call for HTTP, and it makes it really easy. However, the data interface for that, when the message comes over, the array of ints is actually one big string.
Separated by something?
No, it's just one big string, and then converting that string into an array of ints has proved impossible for me at the moment for my lack of Pythonese.
There's nothing in between within that string?
What now?
How is the string look? Is it like 123-456- something?
When I get it printed out, it's either gobbledygook, because it is gobbledygook when you're printing out the things, or when I go manipulating it, it prints out /x and the hex value of all these numbers in a really weird string, and so now converting all of those, it just got to be
Harold.
Too much work.
Harold.
Mm-hmm.
If you're getting a string and it has a delimiter in the string, like a comma or a space or anything like that, in Python, you just use a split command or a split function. It should just split it right up.
I did that too, but I'm not getting commas in between over there. Literally, it's integer.
It
with
sounds
no
like
delimiter.
each byte is one of the integers, so he has to get the ASCII value of each byte.
Yes.
So you get byte 1 is this and byte 2 is that. It still should be doable in Python.
It should be, but I was unable to find it, especially in Python 2.7. Python 3637, some other, I think, has better tools to deal with this.
Yeah.
I ran out of stuff. I've spent, I don't know, 6 or 8 hours trying to make this happen on my streams over the course of trying everything that I could think of. And I even had somebody the other night come on my stream that does Python for a living, and he actually got me pretty far. right up until I saw a bunch of hex values come out, and he looked at it and went, NumPy can maybe help you with that, but I gotta go. So,
Well,
and that's what he does
Harold,
for a living, Python.
if the string either has delimiters, you can use split. If it doesn't
Yeah.
have delimiters, but the int values are on a constant value, you can then split it, character by character. But you should be able to parse a string. I mean, that doesn't require Python 3 for that.
I should be able to do that, but I was unable to do any of those things. So,
All right. Well, maybe hit the mailing list, and we can help you on the mailing list.
okay, I might try it again. I'm actually need to have I'm going to augment my ExoMy here, my Zemo, to understand a start button and a stop button on here, so at least it'll drive forward, and hopefully I can point it and it'll get close enough to maybe get me a point. That's where I'm going for now. And
Harold, I'm with you.
Okay, I'm going to be quiet now. I'll take any other comments you want, but I'll be quiet.
That's cool. I'm with you. So I actually, Harold, we'll see you, David. So I got an update here, and it is Harold, that I have the similar kind of problem as you do, I think, because it must be a software version problem. Because somewhere there is a version of this software that's running, and right now this version isn't. So, so that's my software problem. I'm right there with you. Raj and I were working to get this together, and he was sick at our last attempt to get together, and now we won't be able to work on it. So I'll be able to show it driving straight forward and backward, and if lucky, you'll be able to show it to actually go forward and then neatly back up and go straight the other direction. But that'll be about it. So that's the only update I got to share.
I have one update. Is I went to the basement while my basement was flooding for like the 4th time, and I painted up a whole bunch more of these.
Nice.
So I'm going to be decorating my deck with a whole bunch of pieces of wood like this, and basically building out my my test environment for my robot. Because I've got it to the point now where the PID controller is working and the sensors are working, and I now can let it loose on the deck, I think, this next week.
Very nice.
So that's my minor update.
So a little bit of home decor work. That's good.
Yeah. You can't have a robot that doesn't, I mean, if you don't have like fluorescent striped panels like this, then you're not doing it right. I mean, come on.
It'd be the best looking porch around.
They look really good on YouTube, I'll say that.
All righty.
So are you flying to?
Dude, how can I use this on my channel?
Are you flying to Dallas to enter the competition, or this is for something else?
We're hearing a very low
Murray?
voice.
What?
Glenn, was that question directed towards Murray, Robots New Zealand?
Yeah.
Oh, I didn't hear you.
The question was, where are you doing your competition at? Are you just doing something in New Zealand, or is that part of the Dallas competition?
I've been sitting in on this group for what, Carl, about 2 years now?
About that, yeah.
Something like that, yeah. No, I'm not flying to Dallas. No, and I'm not participating in this particular competition. My robots are not capable of running on grass at this point. So I won't be able to do anything for this competition, no.
Well, Carl,
But Glenn, I originally, before the pandemic started, I was going to start a robot club here in New Zealand. So I bought robots.org.nz, and I've been putting things up there. I've got a blog and stuff like that. And then I started participating with the DPRG, and also started the Discord channel. So there's a personal robotics Discord channel. So I'm kind of just doing things remotely. And there's some idea that maybe and David Anderson was giving me a time for the fact that, like, do I want to build robots or have a club? And it's kind of like, well, I'd rather build robots, actually. So the idea of having a club and being the one to administer it is not that appealing. I'd rather just build robots. So, to answer David.
I'll put your blog in the chat. I'd love to read about it and keep up with what you're doing.
Okay, we'll do that. But you can, if you just go to robots.org.nz, you'll find the blog.
Yeah, you need to get him to install Discord. You can really get into the conversations.
I put an invite link at the beginning, so in the chat on this this chat, whatever, this video, the VTC, whatever we're calling this, there is actually a link at the beginning. So you should be able to find it in the list of pretty much towards the beginning, Carl. I'm looking for it.
Yeah, it's way back. There's been a lot of chat tonight.
Well, I'll go ahead and post it again then. Well, we're almost at the end though, so I probably, let's see.
I think the chat rolled off. I don't think I can get.
I'll see if I can put it up and running fast enough to post it again.
I'll put it down. Here we go. This is
yeah. Carl's my co-moderator on that.
But Murray does have a pretty prolific, really nicely laid out blog site. So it's you might enjoy it, Glenn. That's good. I couldn't find the link off it. What do you say, Robots New Zealand or Robots?
Yeah, I'll just type it in. It's robots.org.nz. It's there.
Okay. Perfect. There you
There's
go.
both a chat. Not a chat. I'm sorry. There's both a blog and a wiki off of that, and a link to a YouTube channel. So
lots of content.
Yeah.
Well, Carl actually had a small update.
Oh, please do go, John.
Just real quick. Let's see. Let's go entire screen. There.
Sorry, we lost the Fox. We had 22 or 20, 21 or 22 people at some point tonight. Totally lost.
Can you see this?
Yep.
Scope readout.
Yeah.
This is what happens when you take a Pololu motor through my motor driver, running at full speed in one direction, and you slam it into reverse. So
yeah.
The basically it goes up to, let's see, the yellow graph up here. The current went all the way up to well, let's see, this is about 3 volts. That actually corresponds to over an amp worth of current here, and that Pololu motor is rated at 3/4 of an amp. So my stall logic kicked in and shut it off when I did that. But if I had this thing under load, it would have broken a gearbox. So,
John, are you using a PID controller?
well, yeah, I do have PID control, but I actually had it turned off at this point. The solution was to actually put in constant acceleration between a change in speed. So now you can see, and this the red plot here is the encoder output of one leg of the encoder. So you can see I'm running along at let's see, this is at 200 millivolts. So that's corresponds to, I can't remember what, it's well under the current limit for the motor. And then when I throw it into reverse now, I use constant acceleration to go from full forward to full reverse. And you can see the current climbing until I reach a peak here at about 600 millivolts. That's about, I can't remember the conversion factor on the current, but it's well under the current limit for the motor. And then it drops off as the motor continues to accelerate. So
well, I think David Anderson has been using, and I use the same term. He's got what he calls a slew limiter.
Yeah, I think it's basically as effectively a slew limiter.
Yeah.
It's when I change speed, I basically change speed at a constant acceleration, and that acceleration is well below what the gearbox can withstand. That's it.
Yeah, because I've got both a slew limiter and my PID controller, and then I even added what has been erroneously called a jerk limiter in the field of physics, and in 2AM bars, there's a jerk limiter. And So between my slew limiter, my PID controller, and my jerk limiter, I now have the inability to damage my motors. That if I switch my speed or my target velocity very rapidly, it'll either be the slew limiter or the PID controller or the jerk limiter that will kick in.
Yeah.
So,
Well, this slew limiter that I implemented is actually operating below the PID control. So basically, it just means that it looks as if the physics of the motor has changed a little bit to the PID controller.
yeah, I had implemented my slew limiter right in my PID controller originally, and then now it actually operates at a higher level now. So it actually works on the velocity, because there's the PID controllers where you convert target velocity to motor power, and I want to slew the target velocity, not the motor power.
And my PID controller is implemented a little differently. It's the dependent variable is position, not velocity.
Wow. Oh, that's right, because you got the spider thing, right?
Yeah, I've got an intended position that I want to get to, not an intended velocity. So,
Right.
I implemented it differently.
Yeah. Makes sense.
All right. Well, so you've got a little bit of progress there, but still not quite there.
Well, when I finish getting all the improvements to the motor controller, I'll build more of these motor controllers and replace the ones that I have to my prototype leg. And then I'll show you some real progress when I've got the leg moving.
It sounds like by that time you could have a proprietary motor board for sale.
Well, I was hoping that I could generalize it. It's a nice little board that I put together here.
Yep.
Just a couple of inch, well, 1.5 inch square. This is just for one motor though. But it's got essentially the protection built in. It's got a little stall LED. If you hit stall, they tell you that it's stalled and you need to restart it. And it's I2C.
Well, it sounds like you made progress with what I guess we've called the slew limiter or whatever. That's good, because you don't want to be tearing your motors apart.
Well, yeah, because that thing's a real pain in the ass to take apart.
I can imagine. Cool.
All right, guys. Anyone else? Did we touch all bases this time? Okay. So there was a question Pat had earlier. Normally we have a meeting for the club on the second Saturday of every month, but because we changed the date around this month for a handful of reasons, there's no meeting this coming Saturday. Instead, we'll have a regular meeting Tuesday, a week from tonight, the 17th, and then we'll have our Saturday competition gathering on the 21st. So until then, Robot on. Take care, guys. Have a good night.